Physics Challenge 1, Special Relativity. A boy see the clock on the car ticking slower, this guy. But driver see boy's clock, the clock above the boy, ticking slower. Is that a contradiction? Well, it is a contradiction in the Newton's world, because Newton's world defines universal clock. There is only one clock for everybody, and universal space. Everybody share the same space, so every event happen in the same space. Okay. Now the difference between relativity and the Newton's world is relativity, every frame means observer, okay, reference frame they call, has its own physics. And every physics law is consistent among frame. So what is consistent means? Consistent doesn't mean it's all values the same. Okay, so for example, good example is this: man standing here, another one standing here, far away. Okay, and the man look at him and say, "Hey, you look very small." Right? Is he small? No. From his observation, "Hey, you look small." So each observer has different view. So are they contradicting? Well, in his observation, this is according to physical law. Whatever far away, there is so-called perspective, looks smaller. Okay? In this guy's observation, whatever he see far away, object in far away looks smaller according to physics law. So physics law is consistent. So they are not contradicting. And each observer has a different observation. So this is the heart of relativity. The difference between Newton's approach and Einstein's approach here, he made a clear distinction. As long as one observer apply physics law, everything works out, then it's okay for another observer for physics law to work out. And as long as those physics laws are same, consistent, then we are okay in this world. So he looked at him, "Hey, your clock is ticking slower." He said, "Hey, your clock ticking slower." They don't contradict. Okay? So that's the heart of relativity theory. Each observer is called frame, has his own observation to others. So, for example, one is moving at the speed v. It's called constant speed inertia frame. So inertia frame, he look at him and say clock is ticking small, But there's no absolute time or location reference point in the universe. From his observation, he's a guy moving away at the speed v, not him. So his clock looks like ticking slower. Okay? And they don't contradict each other, because in each observation the physics law hold perfectly. And that's what relativity means. I hope you enjoyed this video, and please check out this physics challenge, and if you like, subscribe.